Hello and welcome for a new video about Stellar. Today I want to talk about smart contracts using the Stellar platform. But first, a small disclaimer. The term smart contract is borrowed from the Ethereum ecosystem. However, even though you may not use the EVM and a fully fledged programming language, the principles stay the same. The Stellar platform can be used to create predefined frameworks just as much as Ethereum with Solidity, for example. It is merely a matter of possibilities offered by each ecosystem. Moreover, I'd argue that smart contracts applied to the Stellar platform make a lot of sense because the API offers a more constrained and easy access to what defines a smart contract. Okay, enough disclaimer. Let's see what we are going to talk about. So we are going to reuse some of the concepts we talked about in previous videos. The first one is time bounds. As a reminder, time bounds are the property of a transaction to be valid at a predefined date. The second notion is multisig. Multisig is the property of a given account to enforce multiple signatures to generate valid transactions. The third notion is pre-signed transactions. Again, a transaction can be pre-signed even partially in the case of multi-signature. The last notion we will use in our example will be the sequence number. I haven't really explained what it is before, I just barely mentioned it. But simply put, any transaction initiated by an account will increment its sequence number, which is an integer. To give you a bit of why we will use the sequence number. So if you create a pre-signed transaction, you can also set the initiator's account's sequence number at which it will be valid. So all these notions will allow us to constrain the scope of possibilities and transactions of one account in our example. And this will form a framework for a smart contract between several participants. Alright, let's jump on our example. Here is the scenario. So Alice is thinking hard about building a swimming pool in her garden. She's very lucky actually. She asks several contractors for a quote and decides Charlie is her best option. Alice decides to work with Charlie, and they both agree on a payment arrangement and on a third person, Maria, to act as a mediator if things go badly with the work. So we've got Alice, Maria the mediator, and Charlie the contractor. Now, what is this payment agreement we mentioned? Let's imagine that Charlie creates a pre-programmed payment framework and sends it to Alice for verification. In this contract, we find the following constraints. Alice will accept to fund an escrow account if the funds are locked up at least until the estimated date. She can raise a dispute to recover the funds at any time. Charlie, the contractor, will start the work if Alice has locked at least the quoted amount in the escrow account. Alice cannot withdraw the escrowed amounts without raising a dispute. And finally, Maria, the mediator, can never access the funds at any time. If Alice or even Charlie raises a dispute, Maria can sign the funds recovery transaction, or she can sign a funds release transaction. As you may have noticed, this agreement is all about an escrow account and its life cycle. So let's build this account's life cycle now. But first, we'll have to identify what we have. So we've got Charlie, Alice, Maria, and for a moment, the escrow account's private keys. The sequence number will start at n. N is the integer the account will inherit from the moment of its creation. And finally, these vertical lines represent the signers needed to submit a valid transaction from one sequence number to the next. Alright, first Charlie creates a new account with a minimum balance. An account is a key pair. Thus, Charlie knows the private key of this account. The next transaction is for Charlie to lock this account to prove he loses control of it, because he still has the private keys. So he signs the transaction using the escrow account private key to change the signers, making this private key useless. So by the way, Alice sending value to the escrow account doesn't impact its sequence number, so we do not have to take this element in account. Charlie, though, may not start the work till he doesn't see the balance to what has been agreed. So let's imagine that Alice will send the right value after the escrow account has been created. Now, if we consider the ideal case, the next transaction is the payment to Charlie after a given date. the escrow account is indeed merged with Charlie's, and therefore the escrow account existence is discontinued at this point. Now, if things do not go as expected, the other exclusive possibility is a dispute transaction. These transactions are mutually exclusive because they are located at the same sequence number. So this means that if one is submitted to the network and validated, the other one won't be. Now, we want Alice or even Charlie to be able to sign those transactions. So they have to become the new signers of the escrow account via the lock escrow transaction. But how can we make sure that Alice or even Charlie can only choose one of these two transactions? Because for now, they are both signers. So I think this is the essential element you have to understand from this presentation. The way you can do this is by using those two future transactions as signers of the escrow account as well. Transaction hashes to be more precise. So let me stress this out. Adding the proceed and dispute transaction hashes as signers of the escrow accounts with the right threshold mainly locks the possibilities to one or the other being submitted. So this pattern is what allows you to create contract branches with Stellar, and you will see or maybe use them pretty much everywhere. Now, if we go one step further in the sequence number, we apply the same pattern when Maria has to decide who should receive the funds without being able to access those funds directly. Maria is a signer, as well as the proceed and recovered transaction hashes. So as you can see, with time bounds, signatures, and sequence numbers, we have a very constrained protocol of payment, and that is our Stellar smart contracts. Alright, let's speak a bit about the implementation of such a contract. So as you've noticed, the signers of the escrow account are also the next coming transaction hashes, and therefore we have to create the escrow account first to retrieve its sequence number, and then we create the last transactions first and scaffold them back to the escrow lookup transaction. So I won't live code this as it would make this video too long. However, we can explore the code I prepared up front, which I'll link in the description below. So if we look at the code, we see that the first transaction, which I isolated in one file, is pretty simple. It's just a matter of creating a new key pair, and from Charlie's account that is supposed to be already funded, we create a new escrow account. And then from that, we save simply the public and private keys from that account for later use. So if we switch to the create transaction script, as you can see, the structure is that we create each of the transactions in a specific function. So we have, for example, the TX4B. As we said earlier in the video, it's all created in the reverse order. So TX4B, which is the refund of Alice after dispute, is very simply a merge operation where the escrow account is being merged into Alice's, so that the balance is completely merged with Alice's balance. Also, we can see that the sequence number shift is 2, and that corresponds to our schema, our diagram, where we said that it's after n plus 2 that we want this transaction to be valid. Same thing for TX4B. Now, the interesting part will be with the trigger of dispute transactions. Let me show you the escrow lock. So as you remember, after the escrow has been locked, whether you have a proceed transaction or you have a dispute transaction, and we said that we might use those transaction hashes as signers. So this is exactly what's happening here. This create lock transaction function returns a transaction itself, but it takes as a parameter a proceed transaction and dispute transaction. So it means that they have to be created already, which is the case a bit above, and they are being used as signers. So you can see the operations here where we say, okay, Charlie is a signer, Alice is a signer, but also proceed transaction and dispute transaction hashes are also signers. The weight is also important. As you can see, the master weight is 0, meaning that still the private key of the escrow account still has no value. It can't sign anything. However, for low, medium, or high threshold, we need a threshold of 2. And this means that with only, for example, Charlie's signature, the weight will be only 1. But if the transaction that is being used afterwards is whether the proceed or dispute, these weights will be adding up to 2, and therefore it will be valid. If we look at the dispute transaction, it's exactly the same, except that in this case, we use a weight of 3, for example. So Maria has a weight of 2, but whether the proceed or recover have a weight of 1. So Maria alone cannot sign anything because the threshold is 3. Now, if Maria wants to have a valid transaction, it needs to add up with 1 more weight, and the only way is to use whether the proceed or recover after dispute transactions. So that's the way we can constrain our framework as well. Everything at the bottom is kind of assembled. So we create each of these transactions using the previous transaction as a parameter for the next one. And all these transactions are saved as files so that we can submit them later on. I've also added some tests so that we can test the different use case. I used Cucumber.js, and I can run those tests very quickly to show you what happens. But in a nutshell, I'm trying to, to test the edge cases as well as the happy path where everything goes well. But trying to have Maria to withdraw money with her keys should not work, and this is what those tests are validating. Okay, so that's all for this video. I hope you enjoyed it, and you will find the links to this repository in the description below. If you liked this video, please subscribe or press the like button. Thank you very much, and see you next time.